Hey everybody, we are starting a new unit today, which means we are jumping into kind of the meat of geometry. We're starting with some lines, some points, some planes, and some really great stuff. This is also the first video that you're going to see me in front of my PowerPoint and my board, which may become more frequent, so be aware of that. We got the fancy PowerPoint here. I'll be flipping back and forth between myself and the notes. These notes are available to you. You should see them in the folder. It's the PDF and it's the completed notes. So you have those so you can follow along with me. If you want to flip back and forth, you should be able to see everything. Remember to make a new screen for the PDF or for myself. Either one, and you'll be able to follow along as we go, and then there will be some practice problems afterwards. All right, let's jump into this. All right, so what you have here are some very fancy defined terms, which, there we go. Point has no dimension. This is the first definition. A point in space. Usually we're talking about two-dimensional space. Occasionally we'll talk about three-dimensional space. But it has no dimension. Okay? It's a dot. It's kind of, this is the spot. But it has no width. It's not a very big dot. It's not a very small dot. It's just a spot in space. So it has no actual dimension. A line, however, has exactly one dimension. And it will be shooting out in two directions, both of them going on forever. Every single line has exactly 2 points. So if we have 2 points, we can always draw a line between them that will continue on in both directions forever. A plane now has 2 dimensions. So the things that we've talked about so far is a point has no dimension, is just a spot in space. A line has exactly 1 dimension and is just shooting off as a line. And then we've got our plane, which is a 2-dimensional structure, which requires at least 3 points. This is a spot that you could point to. This is like a ruler or a pencil, although it also technically doesn't have any dimension. And then this would be more like a tabletop. Okay? And the shape for the plane can change. But these are the 3 basic things with which we're going to build and construct everything. For example, eventually we're going to get into triangles. Triangles are 3 lines with 3 points. And those 3 points, if you connect all of them, you get that triangle. We're going to get to rectangles, which is very similar, but with 4 points and 4 lines. Okay? So these are the 3 big definitions. An undefined term, such as point, line, or plane, that is not mathematically defined using other known words, although there is a common understanding of what the word means, such as point, line, or plane. We're not going to hit undefined terms very much. Okay? Moving on, postulates is a statement that is accepted without proof. Collinear points. This one's important. Talking about this co. Co means together. If we cooperate, okay? Co means we're working on something together. Collinear means they were on the same line. So if 2 points are collinear, that means those 2 points are on the same line. Same thing with coplanar points. Coplanar points means that we are together on the same plane. So we have a plane over here. We've got a picture of a plane. And on that picture, you see that we actually have 4 coplanar points. There are 4 points that are along the same plane together. Coplanar lines are 2 lines that are on the same plane. So, looking at just these 3 for now, I'm going to talk about them. And let me shift back here. Oh, because it messes with my screen too, so that's not going to work as well as I want it to. Okay, never mind. Let me pop back over here. Looking at these 3, collinear, coplanar, and coplanar. Collinear, same line. Coplanar, same plane. And you can have coplanar points and coplanar lines, but the fact that they are coplanar is the important thing there. Because we know what a point and we know what a line is, but remember, same plane, same line. A segment is a part of a line. Segments are actually what we think of when we think of lines. Lines go on forever in both directions. Segments end. So when we build things, we will typically be using segments. Although segments, again, are usually what we think of as lines. But they end on both ends, as opposed to a ray, which does not. It has a beginning point, and then it shoots off in one direction. So lines shoot off in both directions forever. Segments have endpoints on both sides, and rays shoot off in one direction forever. So, 2 points determine a line. So if you have any 2 points, such as P and Q here, we have a line between those 2 points. Any 3 points are required to create a plane. And that's because of how many dimensions that you need. Okay? We need a one-dimensional object like this line. We need 2 points to create that line through them. Here we need 3 points to create a 2-dimensional object. So, the naming of points, lines, and planes. And this is going to be important, so we're going to make sure that we talk about this. Let me move my face out of the way a little bit here. Okay? Looking up here, the diagram to the right, 3 points. Things are going to be labeled based on what they're next to. So, looking at naming 3 points. We've got points all over the place. But generally, points are going to be capital letters, like D, E, or F, are all points. Q and R, if you look closely, you'll notice are italicized and either leaning a little bit to the left. So those are going to be the names of planes. And then lowercase letters will be the names of lines. So, A, we need 3 points. We have points D, E, and F, like I said, lines M and M. Notice that these are my 2 lines, M and P, sorry, M and P, okay? And then Q and R are my planes, okay? So we're just practicing naming things so that when I say, look at line P, we all know to find the P and the line that it is next to, okay? Now, there are, I don't think this gets into it, 3 points that are collinear. Remember, collinear means that they're on the same line. So 3 points that are collinear. Well, we've got 2 lines as options here. This line has 3 points, so points D, E, and F are all collinear. They're on the same line. Points D, E, F, and G are on this same plane, which sometimes you're going to have to use not your imagination, but look at it a little differently to realize how some things function in 3-dimensional space. And then points H, E, and G do not lie on the same line. And there are a lot of answers for points that are not collinear. As long as it's not in a line, we're non-collinear. D, E, H are not aligned. D, E, G, H, F, E are not. The only wrong answer here would be D, E, F. All right. I'm going to skip over this for now. All right, we're going to draw a really quick diagram. And more than anything else, I want to cover symbols. Symbols are a really big deal here, okay? Notice with lines, we drew a line over AB or BA. Those are the same line, okay? The order does not matter with lines. But in order to signify that it is a line, we drew a line. Lines have arrows on the ends to signify that they keep going on forever. Segments, notice that we don't have those arrows anymore. Okay? That's because it ends. It doesn't go on forever. So to draw it, we would need those endpoints. And for our ray, we've got 2 different examples of rays here. I'm going to move myself. Sorry. 2 different examples of rays. Notice that for AB or BA, for lines and segments, they are exactly the same. Okay? But once we get to rays, things change. Ray AB and ray BA are different because ray AB means A is at the end point and B keeps shooting off forever, as opposed to ray BA, which means B is my end point and A keeps shooting on forever. So pay attention both to the notation, these symbols on top of the letters, and what the diagram is going to look like as well. Okay? Also, sometimes you will see lines or segments or rays that are not labeled with a lowercase letter. This is an alternative way to label them, and is actually the way we'll be labeling them more often and more frequently. We're going to skip over this for now. Okay, we're just going to take a look-see at these. JK, we know this is a line because we see this symbol. It's definitely a line. Lines have two arrowheads, and we don't have any endpoints because lines don't have endpoints. They shoot on forever. KL, looking at that symbol, we see that that is a segment because we have no arrows. No arrows, which means we have both endpoints K and L, where it ends. Endpoints are the points, K and L, where it ends. We are not super creative when we name things in geometry. Okay? Endpoints are where the points end. Okay? LJ is array. We know that because we have exactly one arrow. And because it's array, we'll have one endpoint. Our endpoint will be the side that does not have an arrow. So point L is our endpoint there. This is not actually your assignment. Your assignment is going to get posted in Schoology in just a moment, as soon as I finish writing it. It's going to be about 10 questions of identifying lines, segments, and rays. I will see y'all